Hello, everybody. We are going to talk about solving quadratic equations by finding square roots today. So, a quadratic equation in x is an equation that can be written in the form ax squared plus bx plus c equals 0, where, this should say not x, this should say where a is not equal to 0, okay? You don't want this number here to be 0 because that eliminates the first term and that makes this thing basically a line, okay? So, how to solve something like this. X squared equals d. Well, if d is positive, then x squared equals d has two solutions, plus or minus the square root of d. The equation x squared equals 0 has only one solution, x equals 0. And if d is negative, then x squared equals d has no solutions because you can't square root a negative number. Okay? All right, so let's solve this equation here. So x squared minus 92 is 29. So what we're going to do, we just treat this like any other equation. We're going to add 92 to both sides. So we get x squared equals, that's going to be 1121. Okay, and now I'm going to go ahead and square root both sides of this equation, and I'm going to get x equals the square root of 121 is 11, and it's plus or minus because negative 11 squared is 121, and so is positive 11 squared. So I got two answers, plus or minus 11. Okay, different type of problem here. 4x squared is 36. So the first thing we're going to do is we're going to divide both sides by 4, get the x squared by itself. X squared is going to be 9. Now I'm going to square root both sides. And x is going to be plus or minus 3. Okay, piece of cake. What if I have both of these? I have something out here and I've got something up here. Well, I just take it in steps. Okay, so, I don't know what's a good color to use right now. How about, what's this? Okay, so I'm going to add 48 to both sides. All right, so 3x squared will equal 48. And now I'm going to divide both sides by 3. So x squared is going to equal 16. And now I'm going to square root both sides. So x is going to equal plus or minus 4. Okay, the U.S. population can be modeled by the equation P equals 6,893,000 plus 672,240 t squared, where t equals 0, 1, and 2 represents 1800, 1810, and 1820. So these are basically the decades right here. Use the quadratic model given with the graph to estimate the year that the United States population will reach 300 million. Okay. So we're going to go ahead. We want 300 million to be the answer, so that's going to be the population. 300 million is going to equal 6,893,000 plus 672,240 t squared. Now, what does this equation mean? Well, in year 0, if I plug a 0 in here, that would mean that the population was 6,893,000. That would be the year 1800. Okay? And then it's adding about 672,240 times t squared. So this is increasing at an increasing rate here. Okay, so the first thing we're going to do, we're going to subtract the 6,893,000 from both sides. All right, let's get out our handy dandy TI-84 plus C Silver Edition graphic calculator so that we don't make any mistakes. 300 million. That's 300 million. minus 6,893,000 comes out to be 293,107,000 equals 672,240 t squared. Okay, the next thing I'm going to do is I'm going to divide both sides by 672,240. Okay, so divided by 672,240, t squared is going to equal 436.01. So we'll just say 436. Okay, now we need to square root this to find t. So square root answer. That's going to be, t is going to be plus or minus 20.88. So we'll say, we'll just round it here. Now, we don't need the minus because it's time, so it's going to only be positive. Okay. So this is going to be about the 21st decade. Well, what's the 21st decade? Well, that's when this would be 21, which doesn't, that's about 210 years to 1800. Okay, so 1800 plus 210 years, it's going to be about 2010. And you know what? That's about what the population was in 2010. Okay. Now, make sure you know this is not your answer. This is your answer. Okay, falling objects. So here's the thing, is if you drop something on the earth, it falls according to this equation right here. H equals negative 16t squared plus s, where s is the height at which you drop it. So if I was to drop it from here, this would be like 6 feet. S would be 6. Okay, t is time, and h is the height of the object at any particular time. I would know this formula right here. Okay, so let's put some special color around it. Seems a bit thick, so let's kind of thin that down a bit. There we go. Okay, so I would know that formula right there. Okay, so a construction worker on the top floor of a building accidentally drops a heavy wrench. How many seconds will it take to hit the ground? Assume it drops from 200 feet. Okay, so let's write down our formula. Always write down your formula. Okay, h equals negative 16t squared plus s. Now, this equation doesn't work on the moon. It doesn't work on Jupiter. It doesn't work anywhere else except on the Earth. Okay, so this number, right, the basic formula would, but this number right here is related to the Earth's gravity. Okay, so like on the moon, this might be like negative 6. On Jupiter, this might be like negative 30. Okay, so assume he drops it from 200 feet. So S is going to be 200. So H is going to be negative 16t squared plus 200. And we want to know how many seconds it will take to hit the ground. Well, I have two variables, but I know one of them. H is not going to be H. H is going to be 0 because that's when it hits the ground. It's going to be 0 feet off the ground. Okay, easy to solve now. Add 16t squared to both sides. Okay, so 16t squared is 200. And now I'm going to go ahead and divide by 16. So t squared is going to be 200 divided by 16. That's going to be 12.5. And then I'm going to go ahead and square root those sides here. So t is going to be the square root of 12.5. That's going to be about 3.53 seconds. Okay. Now the thing is the longer the thing falls, the more it's going to speed up. Okay. So it's not going to take very far or very long before it drops 200 feet. Okay, here's your assignment 12-2. There's 2 pages for that. So I will see you guys in class. Have a great evening.